Hi, this is David. I'm here to talk to you about Azure Machine Learning Studio, or ML Studio for short. ML Studio is a way to create machine learning solutions using a graphical interface. And the advantage of doing this is that there are shapes that you can drag onto a form that'll take care of what I call the plumbing of an application. That is, the parts of a machine learning application that are common to all or to many machine learning solutions. Things like getting data from a data source, splitting data between training and testing data sets, cleaning up empty data, things that you'll if you're writing code yourself, you have to write that code over and over again. Well, with Machine Learning Studio, then you can just drag a shape onto it, set some properties, and then you're done. That's code that you don't have to write. And then you can spend your time focused on the things that make your machine learning solution unique, which is where you should be spending your time. Now you can get started with this for free simply by going to studio.azureml.net, or you can go into your Microsoft Azure account and create a Machine Learning Studio workspace and get to it from there, and that allows you to take advantage of some of the scalability that's built into Azure. Either way, you're going to end up here, and you want to click on this Experiments tab and then click this New button down at the bottom left. That'll bring up a list of a whole bunch of sample applications. I would certainly encourage you to look at these. You can learn a lot about ML Studio and also about machine learning by going into them. But for today, we're just going to create a blank experiment. And here you see a design surface right here in the middle. At the top is a title. I'm going to call this one Demo Income from Census Data, because that's the data that I've decided to use right here. And let's design surface, there's a clue of what you want to do. There's a bunch of shapes you'll drag into here and you'll connect them together. They won't have to look exactly like this, but that's just an idea. The shapes you drag onto this design surface are all over here on the left side. And I can expand these things to find them, or I can search for them. If I know they're the name of the shape, I can put a partial match in here. First thing I want to do is to add a data source. There's a whole bunch of built-in data sources that ship with ML Studio, one of which is the very first one, Adult Census Income Binary Classification Data. And it's called binary classification because the income is grouped into less than 50,000 and greater than 50,000. So just two categories here. And that's what we want to predict. We want to predict, given the factors such as age, working class, education, marital status, occupation, etc., can we predict with some accuracy whether or not a person is going to make less than $50,000 or greater than $50,000? And we're going to use this data and this tool to do so. So let's take a look at this data here. I'm visualizing here. We see that we have age, and age is a numeric feature, as you can see over here under statistics. There are no missing values. Every single row has an age. There are 73 different unique values, and because it's a numeric field, then we can do some statistics on it. There's mean, median, min, max, and standard deviation. Those are all in there. And you get a good picture of that data with this histogram right here, showing how it's distributed. A lot of people here are around, looks like around 39 years old, 31 years old, and so on. All right. Now, let me look at that again, because I want to point out a few things about this data. One of these things is that if I look at the native country, I noticed it's heavily skewed toward the United States. 90% are United States. In fact, the next most used one is only 2%. We could probably safely ignore the rest of these. They're outliers. Not going to add a lot of significance to our study. So I think for this, we're going to focus on those whose native country is the United States. So let's do that. Now over here, there really isn't a good shape for filtering. However, luckily, we do have a way of writing some custom Python code. And we can do that filtering with just one line of custom Python code. So what I'll do is I'm going to drag the output of my data set as the input of this Python script. And when I open up the Python script, you'll notice there are 3 nodes here, 1, 2, 3, and if I hover over them, that's data set 1, this is data set 2, and this is a script bundle from if I want to add other libraries. So I can add up to 2 data sets here. You'll notice right here, when I run this, it's this Azure ML underscore main is the function that'll run, and it takes two parameters, data frame 1 and data frame 2. And if it's missing, it'll just set it to none, which in fact, data frame 2 is missing, and so it'll be set to none. And I can add some code in here to filter that data set. I actually have some code right here. So what I want to do is to grab this bit of code here, and do that. I don't even need data frame 2 because I know I've created this. I'm not passing data frame 2 to it. And I specify this code here. I said this filter, data frame 1, data country equals United States. That's a filter expression. If I say filter this data frame based on this filter expression, and then return that to overwrite the data frame and return that, then I am good to go. So let me save that. And in fact, why don't I run this right here? Click this run button down at the bottom, and that'll run everything in here. All two of these shapes will run, and we're done. It went pretty quickly. If I looked at the first data set, you'll notice there were 15 columns and 32,561 rows. The second data set should have the same number of columns, 15, but only 29,170. I got rid of the few percent that were not native country is US. All right, the next thing I want to do is to clean missing data. So you'll notice that some of these things actually have some missing values. So for example, working class has 1,800 rows that are missing. And I want to get rid of that. And there is a shape for doing that. Clean missing data right here. I'll drag that over and set its input to the output of this Python script. And in here, this property sheet, there are some properties I can set. I can specify which columns I want to consider to have missing data. But I think the most important one is this one right here. What do I want to do when it finds missing data? Do I want to replace it with something? Or do I want to just remove the entire column or remove the entire row? That's what I'm going to do. I'm just going to remove the entire row. Nice and simple thing to do. Just get rid of that. Anything with missing data. I'll assume that's bad. What you do is up to this specific solution you're going to build. In fact, if I run this, then I'm done. And here I went from 29,170 rows to 27,504. So I had less than 2,000 empty rows or rows with missing data. I just got rid of those. I didn't want to consider them. All right, the next thing I want to do is as I look at this data, I have to decide which columns do I think are factors in income. And that's a bit of a challenge. I have to have some domain knowledge about this. So the more research you can do about the data and about this topic of income, the better off you are. So you may say, you know, this capital gains doesn't really affect it. I can remove that. Or I don't think that gender is an issue. I can remove that. You think about what those might be. You also want to check for things like redundant data. So you notice over here we have education, and that's high school grads, some college, bachelor's, master's, etc. And we have education number, which is the number of years of education. They seem to be covering the same thing. This is probably, I like this a lot better because it has the years of education, where these are just strings. We have to somehow interpret those strings. So I would add this but not add that. If I added them both, I'd probably be double counting education, which is probably not what I want to do. Let's select the columns we want to add. There's 15 in here, but there is a shape, select columns in data set right here. And you notice that there's a red dot here, and what that means is the value required. So if I come over here in the property sheet, there's only one question it's asking me. It's just select the columns. And I could do this right here. I could do it by selecting them this way, or I go into the rules and say, give me all columns except for these, or say, give me no columns, but then add these. I'll just go by name. That seems simpler to me. And the columns I'm going to select are age. I think that's a factor. Education. I'm going to use this number for the education. Let's see, marital status, occupation, How about race and sex? Those might be factors. Hours worked per week. And then, of course, I want to include, I don't need to include native country because now it only has one value. And, of course, I want to include income because that's what I want to predict right here. So those 8 or so columns right here, I can actually just run that one by saying run selected, and that'll go a lot faster. It won't rerun those other columns, which I didn't change. And here it is. So now I have the same number of rows, but I have a lot fewer columns. Now I look in here, there's one thing that troubled me when I looked at this data, this marital status. You know, it has married and never married and divorced and separated and widowed and some stuff over here, spouse absent, and these are things that have to do with spouses of military personnel. And you know what, I think that's kind of overkill, dividing it all that way, particularly when there's so many, there's essentially everybody that's married in this is one category, and then not married is in several different categories. I'd like to just split that into two, change it from 7 unique values just to married versus not married. That's what I'd like to do. And I could do that with a couple of lines of Python code. And if you want to know how to do this, I actually have a blog post on this from May of 2018. You can look, replacing values in Azure ML Studio. Use the map function right here. And so what I'll do is I'm going to write a Python script, and the input to that will be the output of the step before that. And here's my Python script, which I've saved right here. And what I want to do is I want to say these 3 here should all be just considered married. These 4 right here should all just be considered not married. That's all I really care about. So I'll add this bit of Python code, and you'll notice that there's a map that is essentially a JSON that says, all right, map from married CIV spouse to married, and this to married, and that to married, and then never married and divorced and separated. Match each of those to not married, not married, not married, so on. And the line of code here is to say, data frame 1 of this column, I want to map using this map right above here, and return that data frame, return the results of that. All right, so if I run that selected one, what I should see is the same number of rows, the same number of columns, but one of those columns will be different. It'll go from 7 different values down to 2 different values. And let's take a look at that. And here's my marital status. You can see right now it's just married versus not married. And they're actually a lot closer together. There's 47% married and 53% not married. I actually like that a lot better. All right. Now we want to split our data. We want to train our model using some machine learning algorithm, but we have 27,504 rows here. We don't want to train it with all of that data. And the reason we don't want to do that is because when we're done training it and creating our model, we want to test that model. We want to see, is it predictive? And to see if it's predictive, we have to test it against data that it hasn't seen before. It's really unfair to say, let's give it data that has seen before. It's already matched to that data. We know it should be predictive for that. Let's give it data that's unknown to it, see if it still works. So what we'll do is we'll hold back some of the data. And there is a shape called split data right here that we can use to split data into training and testing data. And by default it'll split it 50-50, but I think I'm going to split it 70-30. That makes more sense to me. 70% for training, 70% for training, 30% for testing. So let me do the training. Train model. That's the shape that I want to use, and I'll use the 70% over here as the input for that. And then it's missing something. It wants to know the what model to use or what algorithm to use to train it. And this is a challenge. You have to figure out what you want to do. And this is the part where you have to actually know something about machine learning. But there are tools to help you decide which algorithm. In fact, if I go over here and down to the section on machine learning, there's a lot of algorithms available to you. Quite a few of them here. Let's think about what we want to predict here. If I look at this data right here, I want to predict whether it's one of two values, less than 50,000 or greater than 50,000. All right, that's just basically two classifications. It's not a numeric scale from 0 to 1,000 with infinite numbers in between each number. We want just two buckets we're going to predict. And there's a tool that helps me out a lot. It's the Azure Machine Learning cheat sheet. So I'm just going to search for that. Machine Learning Algorithm cheat sheet. It's in Microsoft Docs right here. And there it is. If I open up this, it's a PDF document right here. And it says, what kind of detection am I doing? Is it regression? In other words, am I going to try and figure out whether it's some value in a given range? Is it looking for outliers? Is it doing some unsupervised machine learning? None of those are true, actually. We're doing some classifications. In other words, what bucket of these discrete buckets will it call in? And we have some for multi-class classification and some for two-class classification, which is what we want, the two-class classification. So any one of these will work. This one says it's optimized for greater than 100 features, which we don't have. So we'll eliminate that one. But the rest of these things, same thing with this one here. Rest of these things, they look like they'll work out pretty well. So let's just grab one, the two-class average perceptron. Let's use that one. And we're not married to this. We can go back and change it later if we want to, but that becomes the input to our training model right here. Now, once we're done with this, then we are going to want to, oh, actually I forgot to skip here. We got a red dot here. I have to tell it, my trained model, what I'm trying to predict. And what I'm going to try to predict is income right there. All right, but when I'm done with creating this model, this predictive model, I want to see how it did. So I want to score my model. Score model. Let's do that. Bring that in here. And what am I going to score it against? Well, over here I need a data set. I need some data to test to see if my model works, and we actually held back 30% of our data for just that purpose. We wanted to see if this training model works against this data that it hasn't seen before. We also have a shape called evaluate model, which gives us some statistics about how that scoring went right here. Let's run this whole thing. And we can see it running here. There's a little checkbox say which step is running. It's executing that Python script, cleaning the missing data, selecting columns, that Python script, splitting the data, training the model, and then scoring, and finally evaluating the model. So let's see how it did. Click on Visualize under Score Model, and here we see our data again with two extra columns. So here's the factors for each row, and you can see we predicted that a 59-year-old white male who's married, working in other service, 9 years of education, works 40 hours a week. We predicted he'd make less than $50,000, and in fact, it was reported that this particular male does make less than $50,000. So we can see that this one is right, this one is right, this one is right, this one is wrong. It guessed that the 40-year-old white male with a specialty who's married and 13 years of education, 25 years old, it predicted that he would make over $50,000. He's not, and so on. And there's some probabilities as to whether it thinks it would be right or not, so you can wait on those. But that's hard to look at every single one of those rows. Let's look at some statistics about that. And right here what we see is here's the probability. If we just guessed, if we just flipped a coin every single time, there's only 2 possible choices. This is what we would expect. So we want to stay above this. We want to stay as high above this as we can. And in fact, this is not too bad. Our accuracy is 81% given this model. So we're doing pretty well on this. But is this the best model possible? Who knows? One thing we can do, there's a couple things we can do. One, we can go back and we can tweak some of our data up here. Maybe we could, for example, use different columns. If you wanted to assign different weights to different columns, we could maybe double count a column by adding it twice, things like that. Or we could pick a different algorithm. This cheat sheet actually said there's a few different algorithms that will work with 2-class classification. So why don't we just try, how about this, 2-class logistic regression? Let's try that one, and we can do that. We can do that in the same experiment here. Under 2-class logistic regression, we'll drag that over here, and we'll use that to train a model. Let's create another train model right here. So we'll use that as our algorithm using the same 70% training data right here. And we'll have to go in here and tell it that we are interested in income. All right. And then we could score that model. Right here against this same 30% testing data that this model hasn't seen either. And then we can use the output of that in our evaluate model, and then we can actually compare these two and see how they do. So let's run this and see how it goes. So now here we go. We have get our data. That's queued up now. Now it's running. It got the data. It's executing the first script, cleaning up data, selecting columns, executing our second script, training this model, training that model, scored the first one. It's scoring the second one, and when it's done, then it's still running, but when it's finished, we should be able to evaluate the final model. And right here, so if we look at this one here, we can actually see the results of this and say, yeah, that one's right, that one's right, that one's right, that one's wrong, that one's wrong, and so on. But it's probably better to look at some aggregation here. And here, it's hard to tell here. These actually are really close together. If I click on the one on the left and the one on the right. So there's the one, the algorithm on the left. Here's the algorithm on the right. They're different colors, and they're almost exactly the same. So we're really not getting a whole lot different. If we look at the accuracy here, say 82% for the one on the right and 81.9% for the one on the left. The one on the right is slightly better. It may be, we've got these ideas of false negatives and false positives. Did we think it was going to be greater than 50,000, but it turned out to be less than? Did we think it was going to be less than, but it turned out to be greater than? Those are marked here, and it may be that we're getting a lot more false negatives than we are false positives. If we think false negatives are more important, the false are more costly than false positives, maybe we want to tweak that a little bit more. Things like that will play into that. So now we've got a machine learning solution. It's a good starting point. We can tweak this more if we want to, but we didn't have to write a lot of code to do it. I think I had like 6 lines of code total, and it's a very powerful solution that gets us up and running. My name is David. Thank you for watching.